show that the frequency of revolution of a charged particle in xy plane in a uniform magnetic field along the z direction is independent of its speed. Here the particle is moving in xy plane and the magnetic field is along z direction. So the velocity vector and the magnetic field vector, magnetic field and velocity are perpendicular to each other. So the maximum force will be experienced by the charged particle. Now what about the expression for frequency? So we have seen that the maximum force Q will be sine 90, and this will be providing centripetal force. So charged particle will be moving along a circular path, and expression for radius we have found. Now velocity, the power of v is cancelled, and here v is cancelled, mv by r is equal to qb. So expression for velocity can be obtained, v is equal to qbr by m. This is the velocity with which the particle moves around a circular path within that uniform magnetic field. Now when the particle is making one complete revolution, the total displacement or that will be traveling along the circumference of a circular path. So time period nothing but the total distance, or that perimeter circumference, and divided by velocity, because we have seen that it is moving with the velocity qbr by m, and during one revolution 2 pi r and 2 pi m by qb. This is expression for time period. Now we know frequency is a reciprocal of time period. Okay, so in these expressions, both of these expressions, that is time period and frequency, we are finding that it is not depending upon the velocity. So here also velocity expression is not there, and here also the frequency also independent on the velocity of the particle. So we can say the frequency is independent on the velocity of revolution. And the seventh question, electron and proton moving with the same speed in a magnetic field which is perpendicular to their motion, and just express the ratio of the radii of the circular paths described by them. So radius mv by qb, and that of electron, this is mass of electron mv by qb itself, and that of proton, radius of the path described by proton, that is mass of proton. And we know mass of proton that is greater than that of electron. So when we are comparing, trying out the ratio, we know both of these particles, they enter the field with the same velocity, and they are entering the same magnetic field. So v and b same for both, and the charge also, magnitude of the charge also same. So ratio of radii in this manner. So since the radius is depending upon the mass of the particle, because all other parameters v, b, q remain the same. So the greater the mass, greater the radius, and we know the mass of proton is greater, so of course radius of proton is greater than that of electron. Proton moving with the speed of 4 into 10 power 7 velocity value, and the value of magnetic field is given. This proton is moving with this velocity, enters a magnetic field of 2.5 Tesla. Calculate the radius of the path followed by the particle at the frequency of revolution. So the values are given. Just substitute the values in the expression for the radius. Radius expression is mv by qb, and then we have the expression for frequency. So expression for radius, and mass of proton, that is 1.6 into 10 power minus 27, and velocity value is given, and the charge is given. Charge of proton we know that will be given, and magnetic field intensity is given. Similarly, frequency is qb by 2 pi m. Again, just a matter of substitution only, and we will be getting this value. What is the path followed by a charged particle that entered magnetic field at an angle theta? Theta is not equal to 0, and that is not equal to 90 degree. Means at an angle other than 0 or 90 degree or 180 degree. Not 0, not 90 degree, not 180 degree with the magnetic field. Then what will be the shape of that path? Why it causes such a movement? Yes, suppose there exists a magnetic field, and here the charged particle is entering at an angle theta. Magnetic field is maybe uniform, but the charged particle is entering at an angle theta, and if the value of theta is not 0 degree, not 90 degree, not 180 degree, we know if it is 0 and 180 degree, there will be no deviation, and if it is 90 degree, that force will be perpendicular to velocity, and it will be undergoing circular path. Now this velocity, this initial velocity vector of the charged particle is resolved into two components. One component is perpendicular to the magnetic field, and suppose the other component is parallel to the field. Then we know the component of velocity parallel to the field makes an angle 0 degree with the field, that will be unaffected, and the component of velocity which is perpendicular to the given magnetic field, then that will be experiencing a force, and the particle will be forced to move along a circular path. So this perpendicular component of velocity, that will be affected by that magnetic force, and it will be acting perpendicular to this component, so that will tend to move along a circular path. At the same time, see, when the particle is trying to complete one circular path, at the same time the horizontal component of velocity is unaffected. So when it is trying to complete one circular path, the horizontal component of velocity, it will take the particle along a horizontal direction, so it will become an elongated circle, means helix. And suppose it is starting from here, and when it is completing one rotation, by the time the particle is reaching there, so the horizontal distance moved by the particle in the magnetic field during one complete rotation, that is known as the pitch of the helix. What is the velocity of the charged particle if electric and magnetic forces are equal? If the force due to electric field is equal to force due to magnetic field, then we can equate Q will be cancelling, E is equal to EB, and V is equal to E by B. So this is the principle of velocity selector. If we have electric and magnetic field in equal magnitudes, means the force due to electric and the force due to magnetic field if it is in equal magnitudes, then such particles will be having a particular velocity, which will be the ratio of electric field to the magnetic field. So along a particular direction, such particles will be coming out with a definite velocity. So this is the principle of velocity selector. Now how to define 1 Tesla? To define 1 Tesla, we have the expression F is equal to QEB or B is equal to F by QE. Tesla is the strength of magnetic field. So this value will be 1 if we have force 1 Newton, charge 1 Coulomb, moving with the velocity V in a direction perpendicular to the magnetic field. So we can say if a charge of 1 Coulomb moving with a velocity of 1 meter per second in a direction perpendicular to the field will experience a force of 1 Newton, then the strength of that field is 1 Tesla. An alpha particle is moving with the speed of 4 meter per second. What is the force on it? It enters into uniform field of 3 Tesla at an angle 30 degree. Use the formula F is equal to QVB sin theta. So F is equal to QVB sin theta. Alpha particles, the charge is 2 times that of proton. VB sin theta, 30 sin 30 degree. So 19.2 into 10 power 19 Newton. (19.2 into 10 power minus 19 Newton). Force experienced by the charged particle Q moving with velocity V in a field B. Which of these vectors V and B and force? Force is a vector, velocity of particle is a vector, and magnetic field vector. Which of these are perpendicular to each other? So here we have seen that this force will be acting perpendicular to the plane containing both V and B. It means that force is perpendicular to velocity vector because it is acting as centripetal force, that is providing centripetal force, and that will be perpendicular to B also. Next question. A 2 mega electron volt proton is moving perpendicular to the magnetic field of 10 Tesla. What is the magnitude of force on the particle? So here energy of proton is given 2 MeV. So mega electron volt, let us convert into electron volt and then into joules. So 2 into 10 power 6 mega is converted into, and then electron volt is converted into joule. So to convert electron volt into joule, we have to multiply with the electronic charge. So 2 MeV, that will be equal to this much joules. And we know when a charged particle is moving under a potential difference V, that will gain energy E is equal to QV, and we have calculated the energy in joules. So this energy, that is 3.2 into 10 power minus 13 joule, that will be equal to Q times V, and this energy, that is nothing but the kinetic energy because the particle is moving. So kinetic energy is equal to Q times V, and this is the potential, Q times the potential. So the velocity can be calculated. Velocity is equal to square root of 2QV capital V, potential divided by M. Then the velocity of the particle can be calculated. By substituting the value, we are getting it as 2 into 10 power 7. This is 2 times QV, and QV is nothing but energy. So 2 times that energy q is 3.2 into 10 power minus 13 divided by mass of the proton. It will be given in the question, mass of the proton, and velocity is calculated. Now after calculating velocity, the force can be calculated, that is equal to qvb, the maximum force. A stream of alpha particles moving with the speed, uniform speed of 1000 meter per second along positive x direction is undeflected when it is passing through a region where there exist crossed electric and magnetic fields. Crossed electric and magnetic fields means electric and magnetic fields are acting and they are perpendicular to each other. So anyhow the particle is not deviated. So it means that the force due to electric field is equal to force due to magnetic field. They balances each other, so no deflection. So electric force is equal to magnetic force. QE is equal to QVB. E is equal to V by B. Earlier we have discussed this in the case of velocity selector. When particle moving through crossed electric and magnetic field, if it is not deviated, then all those particles will be having a definite certain velocity, that is a ratio of electric field to the magnetic field. So magnetic field value can be calculated, E by V. Alpha particle and proton are projected into a uniform magnetic field with the same velocity such that their direction of motion is perpendicular to the magnetic field. Compare the period of revolution of alpha particle to that of proton. We know the expression for time period, T is equal to 2 pi m by qb, and also we know mass of alpha particle is equal to 4 times that of proton, and the charge of alpha particle is equal to double that of twice the charge of proton. So time period of alpha, time period is 2 pi m by qb, 2 pi into mass of alpha, we are expressing it in terms of the mass of proton. 2 pi m, mass of alpha is 4 times that of the mass of proton, and the charge of alpha, that is 2 times that of the charge of proton. Then taking the ratio, finding the ratio, and the similar terms are cancelled, and here time period of alpha is 8 pi m mass of proton, 8 pi into mass of proton divided by 2 charge of proton into magnetic field, and divided by time period of revolution of proton, 2 pi into mass of proton divided by qb, and this is mass of proton, and this is simplified. So we are getting this will be pi and MP and QP B all cancelled. So this is 2 into 2, that is for 8 by 4. Ratio of time period of revolution of alpha to that of proton is 2. So time period of alpha is cross multiply 2 times that of proton. A proton, alpha particle and a deuteron with the same kinetic energy enter a uniform magnetic field moving at right angles to the field. Compare the radii of their circular paths. So radius mv by qb, and here both the particles are having same kinetic energy. So this momentum that can be expressed in terms of kinetic energy, 2m into square root of 2m into kinetic energy is equal to momentum. So mv by qb can be written in this way, square root of 2m into kinetic energy by qb, because mv is equal to square root of 2m into kinetic energy. And here both the particles alpha and proton, they have the same kinetic energy, So that remains same for both particles, and then magnetic field B also same for both particles. Then it depends upon this root of m by q, because the numerator square root of 2m into kinetic energy, and kinetic energy is remaining same for both particles. Then square root of 2m appears for both particles, square root of 2 into m. Then this radius is proportional to square root of m by q, and in the case of alpha particle, we know the mass of alpha particle is 4 times that of proton, and charge is 2 times that of proton. And a deuteron, the mass is 2 times that of proton, and the charge remain the same. Charge of proton and charge of deuteron remain the same. So this ratio, that is root of, compare the ratio. If it is of proton, we know just root of m by q, and if it is alpha, we are getting it as root of m by q itself, and if it is deuteron, we are getting as root 2 into root of m by q. So rp, this radius of proton and radius of revolution of radius of the path of the alpha particle, radius of the path described by proton to that of alpha, they remain the same, 1:1. And here root 2 times root 2 into m by q. So root 2 into m by q, root 2 into m by q, and root 2 times m by q. So the ratio is 1:1 root 2. Hope it is clear. Radius can be expressed as this relation, and here whether it is proton, deuteron or alpha particle, root of 2 is common for all, and kinetic energy is same for all, and magnetic field also same for all. So what is varying? The mass. Within the root, mass is varying and charge also varies. So in the case of proton, we are writing it as root of m by q, mass of proton and charge of proton. And in the case of alpha particle, we know square root of mass of alpha is 4 times that of proton, and charge is double that of proton. And in the case of deuteron, we know the mass of deuteron is double that of proton, because radius is, that is depending upon square root of mass by charge. So mass of deuteron is double that of proton 2 times, and but the charge of deuteron and proton, they are the same. Then comparing, this is m by q, and radius of alpha also we can, we are getting it as root of m by q itself. So this ratio is 1:1, but here root 2 can be taken outside. So root 2 into root of m by q. So the ratio, this ratio in this order, 1:1 root 2. Now a similar question. Alpha particle and proton are accelerated from rest through the same potential difference. They enter to the uniform perpendicular magnetic field. Find the ratio of the radii of their curvature. So here radius expression we know, and we have seen that this momentum can be written as square root of 2m into kinetic energy, and this is energy. And we have seen that the energy of a charged particle moving in a potential difference V, that is QV. So kinetic energy can be written as Q times potential. So we got the expression for radius in terms of potential, because in the question they have given that both all these particles are entering to the same, the potential difference is same, they are accelerated through the same potential difference. So in the case of alpha particle, so here mass of alpha will come, so charge will be the charge of alpha, and potential, the value of potential remain the same. and q will be the charge of alpha, and magnetic field also remaining the same. And in the case of proton, we know 2 times mass of proton, charge of proton, v remain the same, and charge of proton will come and b remain the same. So mass of alpha is 4 times that of proton, charge of alpha is 2 times that of proton, and then taking the ratio, this ratio are this radius divided by the radius of proton, so multiplying by the inverse, this ratio multiplied by the inverse. So within the square root, this terms can be within the square root. So this 2 will be cancelling, v will be cancelling, so we will be having in the numerator within the root m, that is mass of alpha into charge of alpha, mass of alpha and charge of alpha. So denominator mass of proton into charge of proton. Now here we have charge of proton into magnetic field divided by charge of alpha into magnetic field. Magnetic field will be cancelled, so that will be charge of proton divided by charge of alpha outside the square root. Then charge of alpha can be written as 4 times that of proton, and charge of this mass of proton is 4 times that of mass of alpha, that is 4 times that of proton, and charge of alpha, that is 2 times that of proton. So cancelling, this charge of proton is cancelling, so within the square root we have 4 into 2, that is root 8, and here charge of proton is cancelling, so half is remaining, so that can be simplified. It can be written as 4 root 2 into 1 by 2, so this 2 can be written as root 2 into root 2, so 1 root 2 is cancelling. Then we have 2 by root 2, that is 2 is root 2 into root 2, this is cancelling, so that is root 2 by 1, root 2 is to 1.